acaba de llegar el momento que todos estábamos casi esperando desde ayer, cuando les anunciamos que íbamos a tener en la cobertura del Mobile World Congress el dispositivo, o uno de los dispositivos que más ruido ha hecho en la industria de las telecomunicaciones durante las últimas 2 semanas, 3 semanas, 2 semanas de hecho, desde que lo presentó Alcatel-Lucent en público y nosotros lo pudimos ver por una webconferencia. Y antes de pasar al producto sexy, como ya estamos bautizando aquí antes de iniciar, les voy a hablar rápidamente del libro de Shift, que es un libro también de Alcatel-Lucent, que de hecho pueden solicitar, creo, una copia a través de internet. Se puede, de hecho en TeleSemana.com tienen ya un banner que pone de Shift, pinchen en el banner y les llevará este libro muy interesante, que tiene, bueno, es un libro bastante gordito, que es gratuito y, bueno, pues como es gratuito y tiene cosas de telecomunicaciones interesantes, se lo recomendamos, de Shift. Así que lo voy a dejar aquí, luego te devuelvo la copia, no me la quedo. Así que estamos con Marcus Weldon, que es el CTO de Alcatel-Lucent. Vamos a cambiar al inglés. Marcus, welcome to TeleSemana.
Thank you very much.
First thing first, we are not the main characters here. This is, can you show the lightRadio?
This is the lightRadio. It's the future of radio, invented by Bell Labs, that we announced just a week or so ago. This, remarkably, is what will appear on the cell tower. You've seen those ugly old cell towers with big antennas and radio units underneath and a base station that's in a big hut at the bottom. This is the future. It looks like this.
So this is everything. So this
is
everything. The cabinet.
This is everything in the radio and antenna.
With the antenna up.
Exactly. It goes up the top, and down the bottom is a very small box now.
Yeah.
You still have a little box at the bottom, but that has been reduced to one silicon chip.
So we've seen also, which is a
small silicon chip like this. So you've got this up the antenna, small silicon chip down here. This chip actually can go in here to make a very small cell. It can go at the bottom, it can go back in the cloud. So that's the other portion of the story. That's the only thing that isn't in here.
These two guys,
this
device
and the
chip, do they connect wirelessly, or they have a cable that connects them, or both?
Well, we're looking at an array of options. We're looking at actually a wireless connection, which is a really nice thing, because now you can have that chip sit over, in a neighboring site which is invisible, because our view is that the base station should disappear.
Okay. Well,
like magic.
It has.
Right? It has. So part of the functionality is in here, because the base station used to have the radio. That's gone in here. The chip now can sit anywhere and have a wireless connection to this. So all you will see is this.
Can I just hold it?
You are.
Please, come on.
You can have it.
It's weightless. I mean, it's.
Yes.
Let me just look at the chip, see if I can see anything and get some R&D for my own.
Very good.
So it's weightless.
It's weightless.
It sounds like a joke. Like, excuse my expression. I mean, we saw the huge cabinet during the presentation with all the cables and everything that needs to be in place for a base station to work.
Yes.
With the antenna, and suddenly you guys remove the
cover.
The cover.
And it's this.
And press this.
Now,
okay, this is the future.
This is the future. Now, you can add these up. So this one thing has about 2 watts to 5 watts of capability. So if you want to make a big macro cell, you add them up in an array.
Okay.
So you stack them like Lego blocks.
Okay.
And that makes more power, more coverage, but you can actually have them just reduced to 1.
What about interference between them?
Well, actually, they're designed to constructively interfere to form beams. So the interesting part that I didn't tell you about is they form beams that can be directed to each user. So you construct beams. So if you've got a group of users over here, another group over there. In the old way, you just flooded the signal out in different sectors, and now
that's more efficient.
It's much more efficient to form beams, because you're putting the power from the antenna where the user groups are. So one of the ways in which it's not only sexy, but it's actually higher performance, so it's and lower power, so it's got all the attributes of higher performance, lower power, and modular, so you can create any structure that we want. So that means any type of beam, horizontally, vertically, and control that very dynamically. So in principle, in the end, as events happen, you can change where the beam is focused to get more power where you need it.
Okay, now which technologies are these holding? It's 3G, it's going to have LTE. What are we talking about?
See, that's a good question. All technologies, all frequencies. So it's not just 1800, 2.1, 2.6 gigahertz, and you have to make a choice. It's tunable, so it operates in any of the bands, any of the technologies. So you put this up once.
That's it.
And then you software program it.
Okay, let me ask you this, because we've seen in the market that, or we thought before you released this and nobody leaked it before, which is what it's surprising that you guys were able to keep this as a secret, and nobody was able to do some espionage on your product. But the smallest we went until now was the femtocell.
Yes.
And now the femtocell looks like a huge...
It looks enormous relative to this. Exactly.
So how does this change the femto discussion?
So this is more complicated than a femtocell, remarkably. But remember, there's still the baseband chip, and the femtocell is still a baseband chip. But we've actually received a lot of requests because this looks so cool, could this be a femtocell? And I think of it almost like the Bose speakers, these very cool speakers. And as you say, an iPhone looks cool. Could this be a femtocell in your house?
Yeah.
So our strategy is that this is the macro cell, the big thing. Yeah. It's also a smaller thing called a metro cell, which is sort of an outdoor, smaller serving area. So there's no reason that we couldn't also take that into your home, and this is what your metro cell would look like with the chip in the back. So just like a metro cell, a femtocell, it could be in your home and operating over an IP network. So this could be the future of femto. Okay. As well as metro, as well as macro. So it's everything in one. Yeah, exactly.
Now, this I think creates, and I'm not an engineer, so probably you are the person to answer this, but this creates kind of different way in which operators are going to have to reconfigure or think about how they do their deployment. And I'm thinking that self-organizing networks and this kind of newer technologies where networks become smart, it's not just the fact that you have reduced this, but now you're kind of bringing a new concept to the table of ways of actually constructing the network, because you're going to be able to move these things around so easily that your configuration could be changed very quickly.
Absolutely right. And so the fact that we can pool, we can configure as many of these as we need, software program where the beams are, that's a new degree of self-organization. Also, because the baseband processing, if we pull it back into the cloud, you can now control different cell sites which comprised of arrays of these from a central resource that actually can make sure that cells don't interfere with each other. So there's a lot of optimization you can do dynamically to make sure a cube on a cell over here and a cube on a cell over here don't interfere, and then you can actually have them add together to send more power to a user, something called coherent multipath, or sort of network MIMO. You can have them add together so that they send more power to the important users. So there's lots more optimization you can do. So this really is the beginning of a whole new era.
So I'm thinking, like, for example, we're going to have in Latin America the World Cup and the Olympics in Brazil, and many times operators, they want to beef up an area, and thinking that get a truck full of those and...
That's the answer. You don't need me. Yeah, that's exactly the network design.
I should be to entertain myself.
Exactly, yeah. No, the idea is that you don't need a big... Because this is light, like you said, very light.
It's very light.
And even when you put
this is a prototype that actually works.
This actually works. You can see it in our booth, where we're actually doing dynamically showing how beams are forming from this. And there's a board these mount on, and it works, and it's in an enclosure. You can see it. The idea is that you can deploy these rapidly, then, right? Because you could have them in a macro cell and focus the beam on a stadium, but you could also put them inside the stadium because they don't need a big tower. They're light. We think of them on bus shelters. Someone said on a flagpole, on the side of a building, outside just a little cube. And in a stadium, you could just have them all around a stadium and coordinate them as to increase your radio throughput.